Hey everybody, this is Larry. This is day 15 of the League of Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. And we also have the week 3 premium. So we'll see how it goes. um, Today I didn't do that much. I kind of getting ready for my trip to El Salvador. Um, Also, on that note, if you are in El Salvador, let me know. Let me know in comments, or if you have recommendations, I guess let me know in the comments anyway, or on the Discord. Yeah, I mean, one thing that that I find amusing lately or the last day is that I would drink once in a while, but I actually don't drink that much anymore, just because I don't know. I don't care for the taste. I don't care about the feeling, whatever. But yesterday I had uh I just say way too many drinks. And and if you want to know how that go, you could watch that advent of code day 14, I think, video. Then I did okay, but I think initially I got okay, but I couldn't figure out how to debug because I don't know, and I was not feeling well at all. And you can see that in the video. So if you find that amusing, you can check that out. But yeah, but today let's take a look at today's farm. And we also have the weekly premium problem later, and we also have the Leetcode weekly challenge or weekly contest, like also later. So we'll see. Let me get some water. Okay. So today we have 1792 maximum average pass ratio. Okay. We have pass I total. What's pass I? Number of students will pass. Okay. Extra students, there are another. Guarantee to pass anything. You want to maximize the average pass ratio across all the classes. The pass ratio of a class is equal to the number of students. Okay. So I mean, I think. This is actually kind of a tricky one, I think, but I think you can do this with greedy. This is kind of a weird one, honestly. I mean, my first intuition is going to be greedy, and what I mean by that is just that for each extra student, you just find a class to the class of the lowest pass ratio, and then add that student there, and then just keep going, right? And so I'm trying to prove it in my head. Honestly, I think that's still what I'm leaning toward, but I think that makes sense, honestly. Because okay, so that yeah, I think that still makes sense. It's just kind of hard to kind of figure out which one to do, but of course, if you what you can do is just kind of repeatedly get the the minimum or the cost of the minimum pass ratio. So of course, this is going to be a heap problem, as we kind of I think that also kind of makes it a little bit easier in the sense that we've been doing heap problems the entire week. I guess there was some sliding window stuff, but so maybe that's going to be the idea. If not, then we'll come back to this and we'll see. But in any case, yeah. So we have maybe 4 was it pass total maybe in classes, right? We want to sort, or we want to push heap by just a variable p over t, and this is keeping in mind a float, right? And then maybe just pt, right? Yeah. And then we have a heap, h for heap, and yeah, I know that you can put it linearly and heapify. I don't know. I think in general it doesn't change that much, but yeah. Okay, so then now for each extra student, we just find the lowest class, right? So then now we say, yeah, ratio pt in heap q dot heap pop of h, right? And then yeah, and then here we know that this is gonna be a low ratio, so adding 1 to it should gives us the most ratio. I want to say that I think the problem that I'm struggling a little bit is at least in the proof side, is that I don't know. Like, can you have a higher ratio but with more students, so then like the impact doesn't matter as much, right? For example, if you have like 1/1000, right, and maybe 1/2, and you only have one student, well, this goes to 2/1001, right? This goes to 2/3. So if you only have two classes, that's what I'm trying to figure out. Maybe I'm wrong on this one then, right? Because, okay, so let's say you have two classes, 1/1000 and 1/2, right? So then the average of them is going to be, roughly speaking, yeah, the average it's going to be like, roughly speaking, 1/4, right? I mean, 1/1000, but you could maybe say it's a rounding error, right? But so that's before, right? And then now if you change it to 2/1002 and 1/2, that's like, you know, 0.2% and 1/2, so that's still 1.4 after if we modify that one. But if we modify this one, even though it has a higher rating, it gives you 2/3, right? 2 to the third, which average out to the other one, it's going to be 1 to the third, which means that this is actually way better. So I think my greedy is wrong. I mean, this is the counter example, right? Like, if you can't find a proof, and you could find, I mean, you don't even, it doesn't matter if you find a proof, because it probably isn't the right proof, you're able to find a counter example, right? So yeah, so here, so maybe, so this is definitely wrong. Let me also put in this case so that I don't forget later. Yeah, right, so you have, unless there's some other constraints, no, I mean, that's fine, right? Oops, and then you have like one student, right? Why do I always write it this way? Need to warm up mentally. But yeah, as you can see, yeah, this is closer to 1/3, but if you had added it to the naive 1/1000, so okay, so what can we do, right? I think the idea that we can do, I mean, it's still greedy, I think, but just not this way. This way is a little bit deceptive, right? What we want to sort by is actually the greatest impact adding a student would give you, right? I think that's probably the more smarter way to do it, right? And I think this is a trap. It's an attractive trap, but it's still a trap. And yeah, and then the idea here is just having yeah. So then now what is the idea? The idea is that, okay, we have P and T, right? And then maybe we have the ratio would be, or the impact of adding thing is not P/T. We don't need to sort by P/T. We actually want to sort by P/T minus, or maybe the other way around actually. The after, right? Something like this, right? I mean, I have to add more parens because of, you know, maths. But I think that will give us the answer, right? Except for now we want to maximize this, right? Because that's the delta in percentage in one class. And so now we want to reverse this, which is fine, right? So then it's kind of, yeah, okay. I mean, we could just make it a negative version of this, right? So here, I think now we are pretty happy, right? Except for that we want to max, so we add a negative here, right? And well, I mean, we have to add another parens to make sure. Well, make sure, because the other way would be wrong. So I guess that's pretty much it. And then we don't care about this ratio, and then now we have P and T, right? Yeah. And then now we want to add a thing, so maybe we just use the heap still as storage. We go, okay, well, now we P+1, T+1, right? And then we just do it again. We push this thing. I guess we could copy and paste then. And maybe we could even have a helper function. Maybe that's a little bit cleaner. But yeah, and then at the very end, now that we've handled all the extra students, we can just look at, you know, for PT in heap, right? We can just get the average of the ratio, ratios. So maybe like a total ratio, and that's it, right? And then total ratio we added by P/T. And then at the end we just return total ratio over n, right? And that's pretty much it, hopefully. Yeah, kind of a very sneaky problem, honestly. But did I forget something? Oh, I forget the extra parens to make it a tuple. Oh, maybe I just removed it. I don't know. And this is why, you know, you want this is why you want a helper, so you don't have to do it twice. Yeah, that's pretty much it. Looks like I got it pretty quickly last time. I'm curious how I did last time. 1720, yay. Did I just do it this way last time, or did I do anything smarter? No, I basically did the same thing. Good job, Pass Larry. But yeah, actually pretty much exactly the same. So I guess, you know, I thought I was being clever this time. I don't remember this farm at all. But as you can see, it's very easy to fall into that trap. But you want to kind of, this is the impact it has. And the reason why this impact works is because the average function is linear, right? I mean, so the average function is like the sum of the ratios over n as we have here. But it's linear, right? You could take out the n, the 1 over n, and then it's just a sum, right? And because of the sum, maximizing the components will give you the best benefit, right? And maximize the component means maximizing. So that means that independently, when you're able to maximize the delta of one component, it will be able to give you the answer. And that's pretty much it. Yeah. As you can see, I mean, there's a lot of heaps and stuff like this. There's n items inside the heap, and there's gonna be extra student. Let's call it S for extra students, or S for students. I don't know, but yeah, it's gonna be S log n plus n log n. Though I guess you can use heapify to kick it off. But so it depends on how you. So maybe this is where the inefficiency actually matters, I suppose. So maybe we can rewrite this. Because usually, why I don't write it necessarily that way is just because I'm lazy. But also because usually that's not the limiting complexity factor. In this case, it does show them in the complexity actually, right? So maybe it's worth writing it. But usually it doesn't show up in the complexity because you have to do n log n in other places anyway. That's why I did it that way. So yeah. Yeah, didn't change that much. So, but yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.